Hey everyone, welcome to this crash course on Java programming. In this crash course, we will see a quick introduction to Java with hands-on tutorials for all the basic fundamentals like installation of Java, objects and classes, object-oriented programming concepts like abstraction, inheritance, polymorphism, and encapsulation. Followed by that, we will have loops in Java, collections in Java, and exception handling in Java. Also, we will prepare you with the most frequently asked interview questions. All of this under 4 hours. So without further ado, let us begin. But before that, if you wish to keep yourself updated with all the cutting-edge technologies, then subscribe to our channel and hit the bell icon.
Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, servlets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to bitcode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. Each button on the remote performs a different task. Methods in Java are the same. We can have methods to add 2 numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in two different places where their tasks will differ.
So now let's download Java. Let's go to Google and search for Java download. We'll go to the link we see here, oracle.com. So now here we have the web page. Here we can see Java SE 13. So this is version 13, but this isn't the one we are going to download. We're going to download the 8th version, version 8, which is here. Now we're doing this because 8 is one of the more commonly used versions of Java. So let's click this, and here we'll go down. We need to accept the license agreement before we can download it. Now we have two versions here, x86 and x64. Now you can download it depending on what version your operating system is. Now if you do have a Windows 10 operating system, it's highly likely you have a 64-bit version of Windows. Now if you do have a 32-bit version of Windows, you can take the x86. So let's download this. So we've actually already logged in, so we just need to run the installer file now. Let's go to downloads and run the file. So here we have the installer. We'll go to the next step. We'll select this to next. Here we can see where the file is being installed to. We'll go to next. Now if you want to change where you want to install Java, we can press the change option. I'm just going to keep it here. We'll press next, and let's commence with installation. And there we go. The installation is now complete. So we don't need any tutorials or API documentation. So we'll just finish off and go to close. Now to see if Java is installed in your system, we can go to command prompt and type the term javac, which refers to the Java compiler. Now as you can see here, this shows a number of different options you can choose from. This also indicates that Java has been successfully installed in your system. Now if the installation was not successful, you'll see something like javac is not recognized as an internal or external command, operable program, or batch file. But since we've done it successfully, this is what will be shown. Now we're going to set an environment variable. Now what exactly is an environment variable? Now assume you have a file which has a .java extension. This environment variable tells the computer that the Java program needs to be called to run this particular file. So to set the environment variable, we'll need to go to control panel. Here go into system and security. Go to system and select advanced system settings. And then this shows up. Now before we go into environment variables, we'll need to go to where the Java file was installed. So let's go to this PC, C drive, program files, and here let's go to Java. So let's go to JDK, which is the Java development kit. Let's go to bin here and copy this path. We'll go back to environment variables, select path here, and then press on new, paste this, and OK. Now we'll go back and go to JRE, to the path of JRE, which is Java runtime environment. We click on this, bin again, and copy this path. Select this one, new, and paste that. And there we go, the environment variables are now set. Now let's talk about running that simple program I told you about. Now this is possible with the help of an IDE. An IDE, or Integrated Development Environment, will give us a platform to code Java. We will be using Eclipse and IntelliJ as they are popular and commonly used. That being said, there are several other IDEs that are available in the market. So now let's work with Eclipse. Let's go to Google and search for Eclipse. We'll go to this link, press download, and then this shows up. Let's click on download. Now we've already downloaded the software, so I'm just going to directly go into the install phase. Downloads and select Eclipse. With this, you can see that there are multiple options for you to choose from. So we're going to select Eclipse IDE for Java developers. Now you have other options like for C and C++, JavaScript, PHP, and so on. But let's go to the first one, and here you have the details. You can change them if you want, but I'm just going to go ahead with installation now. Press accept now. Here we remember accepted licenses and press accept. And then here as well, we'll remember accepted certificates. Select this one and accept selected. And there you go, the installation is now complete. Let's click on launch now. So here we are setting up a directory as a workspace. I'm not changing it here, so I'm just going to go with launch. Here we have the Eclipse workspace. Now let's close this first. And here we have the package explorer. Now in case this doesn't show up, you can go to window, show view, and select on package explorer. So now let's go to file, new, and Java project. We need to set up a project name. I'm going to call it my project 1. Go to next. We'll go to source. So this is where the source code for your program is going to be stored. Then let's finish. And now we'll click on my project 1, go to source, right click, new, and create a class. I'll name the class my class and create it. And here we have it. So now let's write a simple program to multiply two numbers. So now let's write the main function. Open a bracket. Now we're going to initialize the first number. Now the second one. And finally the output. And finally the variable that will store the output. Now we'll just give them a simple print statement. Now let's run the code by clicking this option here, using myclass.java, and there we have it. Here the product is shown to be 100, indicating that the program is running successfully. Now we're done with Eclipse. Now let's move on to the other IDE I was talking about, which is IntelliJ. So for that, again, we'll have to go back to Google so that we can download it. Search for IntelliJ download, go to this link here. So here you can see that we have two options, the Ultimate Edition and the Community version. Now here the Ultimate version has way more options, as you can see here, but it's a paid version and only has a free trial. Now the Community version is free, so that's what we're going to take. So we'll click on download here. So I've already downloaded the software, so I don't need to do it again. So I'm going to go to downloads, and so here we go. Let's just click on next. Select the location where you want to install it. Press next. Now we will add a 64-bit launcher shortcut on the desktop and create associations. So basically this means that these are the different file extensions that this will support. So .java, .groovy. And now let's go to the next step. We'll install now and we'll wait. And there we go. The installation is now complete. Let's not import any settings. We'll accept the privacy policy. We'll set defaults. Now let's create a new project. So here make sure your project SDK is set to the version of Java you've installed. Make sure this isn't blank. We'll go to next. Here you need to select this option, which is the create project from template, and we are now going to create a command line application. Press next. Name the project, which I'm going to call my project 2. You can change the location if you want. I'm just going to keep it the way it is, and then click on finish. So now we're going to create a simple program through which, based on the user's input, we can determine whether a number is even or odd. So first we're going to import the package scanner through which we can take the user's input. Next, let's go inside here. Let's create the variable reader. Now let's ask for the user's input. Enter a number. We're taking in the value now in the variable num. Reader dot next int. So this is with which we'll be taking in the value from the user. So we're going to set up a condition to determine whether the number is even or not. So if the number when divided by 2 provides the remainder 0, it indicates that it's an even number. We'll show them then. Now for the else case, the number is not even. Or in this case, odd. There we go. We're done. So let's run this program. So let's enter 12. The number is even. And there we go. We have a successful output. This indicates that the program is running successfully.
So let's look into what Java Development Kit means. All the Java applications and applets are developed using the Java Development Kit, that is JDK. Now, the JDK consists of the Java runtime environment, an interpreter, a compiler, an archiver, and a document generator, and a few more tools that go into developing a Java program. So now, let us have a look at the components of JDK. Java Runtime Environment, JRE, primarily is a part of JDK, and it can also be termed as Java RTE. The JDK provides the minimal amount of requirements needed to write and compile a Java program. JRE consists of the JVM, supporting files, and the core classes. The JVM is key to both JDK and the JRE because it is embedded into them. Now, whichever Java program is being run, the JVM is that component of Java that executes a program line by line, thus giving itself the work of an interpreter. We are now in a position to deep dive into the process with which JDK, JRE, and JVM work. Let's take a source file and save it with the extension .java. This file is compiled and converted into a set of bytecode which changes the file extension into .class. This is done specifically by the JDK. Now, here are the steps that follow. Class loader. It makes sure that all the necessary classes are loaded in the time of the execution of a program. Next, bytecode verifier, that is JVM. The bytecode verifier checks the code for errors or irregularities based on access rights on objects or implementation of pointers. It makes sure that the code fulfills the specifications of JVM and does not break the system integrity. And finally, interpreter, which is JVM. Now, while running the program, the interpreter loads, checks, and runs the code. The implementation is made by the JRE, which is the final process. The latest release is JDK 9 and it was released in October 2017. But it was in JDK 8 that a new feature called the Java Lambda expression was introduced that changed the face of Java. Now, Java Lambda expression is a kind of function which does not need any class to be created. It has been included in the latest version of JDK as it provides a clear, concise way to pass functions around. This also replaces earlier bulky anonymous classes and reduces code verbosity, that is, the length of the code. The syntax for the Lambda expression is this: argument list, arrow token, body. Now the syntax consists of three components, which are argument list. This can be empty or non-empty. Next, the arrow token. Now this is used to link argument to body. And finally, body. This contains the statement that works with the function. Let us now just see an example of using Lambda expression and contrasting it with how code would have been written with anonymous classes. This is the old method and this is the new method with Lambda expression. Just have a look at how lambda expression syntax has been used over here. The JDK 9 has been released recently and it seems promising with respect to new features and abilities. Here are some of the features. The first one is Java Platform Module System. This module allows strong encapsulation and declare explicit dependencies. Next, JShell. With the help of JShell, one can directly start writing the code on the console and execute them. Improved Java Doc. Java docs have got the search right in the API documentation, and as an added bonus, the output is also compliant to HTML5. Next, Stream API. The Stream API, also introduced in Java 8, allows programmers to easily parallelize code for improved concurrency and introduces functional programming abilities to the language. The Stream API, in conjunction with Lambda expressions, also comes in handy while iterating, filtering, and extracting large amount of data. The release of multi-jar makes it possible for codes to be run on the newer versions of JDK to be released. So, to sum up, it can be said that Java or JDK is one of the giants amongst all the programming languages available in the market, given the fact that it's being widely being used in the industry. With the latest release of JDK version 9 and the interesting new features it brings along, it is pretty evident that Java is going to break newer grounds in the world of programming.
So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes, and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating, and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using IntelliJ. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name, and student's age. There we go. Now we have these three variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need two classes for this program. So I'm going to create two classes. First, I'm going to name it as bikes, and the second class, I'm going to name it as cars. So let's create variables for these classes. So in cars, first I need string, name, and I need the cost of the car. So cost can be integer as well, because I'm going to use $sign in that. So I'm going to use string because of that. So same thing I'm going to do with bikes.
Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer, so I'm going to use B1 till B5. And I'm going to name them from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars and let's name it as Lamborghini. Similarly, car2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4, Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do it 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I am going to assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste. It will be a lot faster and easier to do. Car 2, car 3, car 4 and car 5. We don't need this. As per car 2, let's take it as 252,000 and let's make it as 3 million. As per this, let's keep it as 1,400,000 and lastly let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models, and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these values. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm going to ask which one would you like to choose. To enter the choice, I'm going to use one more variable. Let's say n. So I'm going to store n. If n is equal to 1, that means Harley Davidson. Then I'm going to show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4 and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari, then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for Ecos. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1. And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm going to enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student. And yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars. And then I'll create one more class with the name bikes. And then one more class automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double, and let's say fuel. And then same thing, private, double, and then year. And let's take one more, private, string, and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm gonna start with the code now. It's a very simple code. First I'm gonna create the variables or the objects of the class with private bikes, bike. So one is car and one is bike. Both are objects for the classes. So I'm going to use these objects. Bikes, bike is equal to new bike. This is so that my object can function really well. And now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed. And the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm gonna do with cars. Now how does a car start? With a key. So I'm gonna make a function public key, and inside it I'm gonna print the same message, car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message, car has been started with key rotation. Let's write that as well. So in the main program I'm gonna use objects to use those functions, and let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions. So if I execute it, these are the error messages that I'll get. Cannot find the symbol method kick or method key.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is, the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is, an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. For example, I have named my class as Simplilearn as shown here. Followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then, the return type of the method. As of now, I have used void. Then, later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So, this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So, interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java Project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select New, and inside New you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right-click on the package and select New, and inside that, let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the employee class, and gets executed to generate employee details. Now, let us try to execute this program and see the output. To execute the program, just right-click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here, the class student is the abstract class and three different student classes, namely Raju, Pranita and Punit, will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method which is interest. So we have the classes Andhra Bank, Bank of Baroda, IDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks is been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are: the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are: Abstraction is expensive as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is object relational impedance mismatch in the case of RDBMS, and the last disadvantage is object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
What is Java interface? An interface is a container that stores the signatures of the methods to be implemented in the code segment. It's really hard to define interface because it's the meta of meta. It's basically a control object. And so you see these in projects where whoever is in charge needs to have a very high level of control of what everybody else is doing. Do you have to have an interface when you're doing programming? No. But if you're in a large project, you probably want one as director, or if you're receiving it, you might get the interface which you're supposed to use in your programming. So when we talk about the need for interface in Java, it's a total abstraction, and it's only the methods. We're not talking about any variables or anything like that, just the methods. You can do multiple inheritance, so you can inherit from different interfaces, and you can do loose coupling. And when we talk about loose coupling, you can think of 100 programmers working on a huge software package. And they really don't know what the other programmers are doing. They can't meddle with it. They can't mess with it. They have like a nice direct place they can do, and they have the information they need in the interface. So we'll talk about the syntax of the Java interface. The interface, then you have your interface name, and then you declare your constant fields, declare your methods, default method. And really, to understand this, we just need to take a look at an example in Java interface. And we're going to do the Java interface defined area. Just kind of a fun little code. For this, I'm going to jump into Eclipse. And we'll go ahead and create a new package. There we go. And we'll call this interface. And we're going to go ahead and add in Java. It won't let you do just straight interface because that's a reserved word. We'll go ahead and create that. And then underneath our package interface Java, we want to go ahead and actually add in an interface. And so we go underneath here, new interface, and let's go ahead and call this one, we'll call it area, interface area, and finish. So now we have our package and we have our area, and this is just the same package we did with our polymorphism and inheritance. So now we have a package, and we've added the object of an interface. And note that the interface is always public. You never have a private interface because it's a meta file. So it's always going to be accessed by other people and by other classes. And as we're creating these methods, this works just like you would any other method. I could easily put integer, and then we have maybe integer side 1, integer side 2. So you can see how you can do, like for the setup, this is going to be just like you do the rest of your class and the rest of your methods. But we're going to keep it simple. And we're just going to do void square, and let's go ahead and do public void rectangle. We'll put a rectangle in there too. So now we have a basic interface, in this case for area. One of the cool things about interface is I can go in here to create another, let me go back into my interface Java, and we'll do another new, another interface, and we'll call this area curves. I don't know, just making that up. So we have our area curves, and maybe in this one happens to be for a circle. So we have our curved areas. Let me just go back in here. And maybe we'll do not only a circle, but an oval. There we go. So now we have our circle, oval, or ellipse, depending on what you want to use on here. And I can go back to my area, and just like you can in classes, this extends area curves. So now I can also do the extends, or in the case of inheritance, same as in a class. Exactly the same. It just makes it easier if you have a hierarchy of stuff coming down in your interface. Now we'll go back in here to the package. Oops. We're going to go back here and create a class, and let's go ahead and do that in here under our interface, new class, and we'll go ahead and call it shape area. And so now we have our new class, shape area. How the heck do we use our inheritance area in here? Well, we just go ahead and do implements area. And so once we do that, we now have area, which happens to extend area under curves. And let's go back in here to our shapes area, the class. And what I want you to notice in Eclipse is the shape area has an underlined red. And if I hover my mouse for it, it's kind of hard to see here a little bit. I'll give you some options there, which will say, bring in your implements. You're implementing area, but you didn't do anything with it. That is what interfaces are all about. It's about forcing someone to show an error here. Now in Eclipse, I have it set so it won't throw an error if I run the program, but it's going to tag it. So even if I compile it right now, let me just go ahead and run this, even though it doesn't do anything, it still has the shape area underlined. And then it comes up here and also puts a little exclamation point at the top when I actually do some actual coding in here. Let me go ahead and do that so you can see what that looks like. There we go. We'll put in our main and we'll initiate our instance of shape area. And we'll go ahead and run this. Doesn't actually do anything. It's going to compile all our different pieces on here. And you still see the shape area is got the red light underneath of it. When it pops up, it says, hey, you have some unimplemented methods. Make type shape area abstract, or different solutions on there. It's because we don't have the actual code. It's saying, hey, you were told to use what's in area and you're not using it. Again, this is all about being in control. And so we have in here, when we go back into area, oops, that's area curves. Let's go all the way to area. We have to have square and rectangle in there. And because this extends area curves, we also have to have circle and oval. And so when we put that in there, we have to do an override. Just so our package actually does something, let's go ahead and bring in the scanner utility. This is just capturing your keyboard. That's what that's for, the Java utility scanner. And then we're going to go ahead and do our override. We use the @ symbol, override. There we go. And then we go ahead and take a look at what we had in area. Well, in area we had square, so let's go ahead and grab the square. This, of course, is just being very lazy and not having to retype it. So we have our public void square, and then we wanted to do something in here. In this case, we want to go ahead and create a scanner for the keyboard, and we'll do a new scanner system in. And that's all that is we're going to do, we're creating an object so we can capture keyboard input and request information from people. And since this is a square, let's see, we're not going to get too caught up in the code here. Oops. There we go. And we'll go ahead and do geometry of a square and compile it and run it. It still lets me compile and run it. And you can see down here it actually says, hey, enter the length of the side of the square. We'll put in 5. And the area of the square is 25. So when we look at just this part, we have it accesses the square, prompts us for our input, does the math of the square, and is fully functional. But I want you to look up here. It still says, this still has an error. It still says, hey, you're missing the stuff in here. You don't have all the pieces you're supposed to have in here. So if we're missing the pieces in the implements of area, we need to go ahead and put those in. Now, we're not going to go through and do all the different areas and walk through each piece. But we're going to look at this. When I put in our rectangle, which is, we have the square and the rectangle, and then we had the circle and the oval, you can see that the error goes away. So I no longer have a shape area with an error on it. And if I run it, it of course will still compile. There we go. And if I come down here, forgot I got to put in something for the square. We could also, instead of square, just do whatever it is. You'll see that circle still functions, although it's just going to do a printout as opposed to what we had before, where it takes in all the information, computes the area. This is what implements is about. It's about taking all this stuff and pulling it in and forcing the programmer or the people in the team to use the different methods that they need for that particular class. And there's one more thing that we want to do, and I'm going to take this extends out here. And then we're going to go back to the shape area, and you're going to see it's going to give me another error on here, a slightly different error. And the reason is that I did overrides, but these don't exist, so they don't know what I'm overriding or what the setup is. And let's say instead of importing area, instead of having area inherit area curves, we could also just implement area and area curves. And then you'll see that the error then goes away when I run the compiler. There we go. And this should remind you of something we talked about in inheritance. Inheritance, we were discussing in classes how you have a diamond effect. You can't inherit from two separate classes. You can implement two separate interfaces. That means that if you have, you're the head of a project, you can now say, hey, this class needs these different pieces. So it's a very powerful tool, and it's one of the ways to force programmers to put in the modules they need and get around the diamond effect. Let's take a look at interface nesting in Java. Nested interface is a procedure declaring a new interface, either an existing interface or inside a class. And let's go back into here, a little play area. Let me just close these out real quick. And let's go ahead and add another package in, and we'll do new package. And we're going to call this, well, instead of interface, let's call it nested interface. There we go, our nested interface package. Finish. And once we're underneath this package, we want to go ahead and add in an interface. And we'll put a new interface in it. And we're going to call this, this is going to be a little confusing, interface outer. And then in our interface outer, we're going to go ahead and create an interface inner. Let me put that in this. So here's our interface outer, here's our interface inner, and our void inner method. And then let's go ahead and add in a class, new class, and we'll call this the nested, oops, and we'll call this the nested IF for interface. And let's go ahead and finish that. So here's our class. And in our class, we're going to go ahead and import inner interface.interface outer.interface enter. Whoops, forgot I changed the name to nested interface for the package. So we're going to import from our package nested interface, interface outer, interface inner. And that just means that we're going from here's our interface outer, and here's our interface inner. You can create a stack of interfaces so that when you send the package out, instead of sending out 50 different interfaces, you can send one interface out with all the sub-interfaces embedded in it. And you can see it highlighted there. The nested if still comes up with an error because we haven't done our override. And we'll go ahead and put in a public here. And we'll just initiate our nested IF class. I guess nested if. There we go. So let's go ahead and initiate that. We're going to have our object equals a new nested if. And again, if we compile it, and we'll go ahead and run it, and I'll do the compilation here, you can see that it compiles fine. It's not going to give you any errors. But when you hover over here, it says, hey, you need to add unimplemented methods. And you left some stuff out of here that you were told you're going to include, which was this interface inner. And of course, we can simply do that. There we go, make it look a little nice. Do our override. And then once we have our override, we need to go ahead and create the method. So it's telling us we have to have that method in there, or we're going to get an error. And that was our inner method that we included. And then it's whatever we decide to do in here. Let's say we wanted to go ahead and we want to find the first 15 prime numbers. And our team in the back put together a little piece of code for that. It's always fun to throw something in interesting, so you're not just looking at a print. I did something really cool here. That can get boring after a while. So we'll go ahead and do integer. We're going to iterate equals 0, number equals 0, x equals 1, y equals 1. And then while number is less than 15, y equals 1, and we iteration equals 0. So forth. You can see here we're doing what is, if you divide, is there any leftover? If there is no leftover, then that means it's divisible. That's not a prime. Otherwise, if the iteration equals 2, system out is going to print the number, and then we're going to add another number to it and just keep looping through. So you can see right here, this is just a simple set of code, but there goes my error. My error is gone. That's what's important. We have our inner method. There's no more error on here because we've now included it. That came from our nested setup on here. And of course, if we're going to put a code in there to count the prime numbers, we should probably go ahead and do our object method and run that. There we go. And sure enough, we have our 2, 3, 5, 7, 11. There's our list of prime numbers. So just to kind of hammer it home, what is the difference between interface versus class? Interface, keyword used is interface. Keyword used for class is class. Interface does not include instructors, where class has its constructors in there. Interface stores only methods, only the method signature, where class has the storage of the actual definition. So just the signature versus a full method in there. There's no access specifiers in the interface, where of course there is access specifiers are needed in class. No data members, includes data members in class. No static members, includes static members in class. So think of the interface as being just instructions. They're instructions on methods. That's all they are. They say, hey, you have to do this as a programmer because your head of your department said this is what needs to be in here. Or maybe you have a very complicated code with a lot of the same pieces, and it says, hey, don't forget these pieces because we're going to give you an error if you don't. What are the advantages of interface? Well, using interfaces has increased the simplicity in programming. Some of the advantages are complete abstraction is achieved with no ambiguity. And that is very key. That is a whole thing. It's saying, hey, we need these in this class. You have loose coupling between the data and methods. So now your team can have what they need without having to go through and understand what the whole picture is. They can build on small pieces and really focus on it. It resolves the diamond problem. Remember from classes, you can only inherit from one class. Now I can come in and say, hey, these procedures, these methods all need to be in here, and I can have as many methods as I want in there. It resolves the complexities in defining dependencies. So again, you have this whole archive, and it's almost like telling a story. This is what we're building. This is what it looks like. Disadvantages of interface. Using interfaces has some disadvantages. Obviously, the first one I look at is if you're working on a really small project, you've added a whole layer of complexity to it. So when you're working on smaller projects, you almost never see interfaces. The interface in the real world project is used either extensively or not at all. And so you will see, instead of an interface, they'll just send you a list of what you have to have in there. That's pretty common, but with the interface, it forces the programmer, so when it goes back up the chain and everything needs to be put together, and so it gets a little confusing because some people are like, oh, I got to use an interface, or I don't. And the use of the interface can reduce the execution speed. You're adding a whole nother layer there where it has to look that information up. And so if you're doing like a huge multi-task process and you're spreading it across multiple processors, and so now you have hundreds of these classes that are pulling in hundreds of these interfaces, that's going to add a little ding to your speed, and it might not be something you want to do there for a process like that, which is very different where if you're writing a game and each player and each module for their character, which has certain things they have to do, which is move left, move right, move up, down, and then they have all the new games always have a special thing they can do that has to be embedded into that class.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is, it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are, first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next. Next. And I'm gonna name it as Encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class. And I'm gonna name it as employee. So in this program, we are going to use a classic example of employee using employee name, ID and salary. So in this class, let me create variables. First string name, then integer ID and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that, I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.setID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First, I'm gonna set everything. And lastly, e dot set salary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this I'm gonna go to a print statement and then name and e dot not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case that's Simplilearn. And next will be id and e dot get id. And lastly salary, e dot get salary. So this is a simple program that is used to define encapsulation. If we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables, so that it's secure and no one can access the variables directly. So now let's run the program. And there we go, we have our result. We have executed the program successfully, and as you can see, name Simplilearn, ID is 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse. Now let's see what is inheritance. When one class inherits some properties and attributes of other class, it is known as inheritance. Let's have a look at an example. In this example, mobiles is a superclass that have variables like cost, color and RAM. The classes that inherits the variables and methods of mobiles are Samsung, Xiaomi and Nokia. These classes are known as subclass. Now let's see the types of inheritance in Java. First, we have single inheritance. In single inheritance, one class inherits features from another class. As you can see above, class B inherits all properties of class A. This is a simple concept of inheritance. Next, we have multi-level inheritance. A derived class inherits from base class, and derived class also act as a base class to other class. Sounds complicated, right? Now let's see this example. Class B is derived from class A. Then class C is derived from class B. Because of this, class C contains properties of both class A and B. This is very effective when you go for inheritance in big programs. And lastly, we have hierarchical inheritance. In this, one class serves as base class and two or more classes serves as derived class. As you can see above, class B, class D and class C have a single base class A. So three classes inherits properties of single class. This is called hierarchical inheritance. Now, to understand these all concepts better, let's use Java code. So now let's create a new project. Next, and I'm gonna name it as inheritance. So we have our main program here. So I'll just create a new class, new Java class, and for now let me just name it as mobiles. So what are the features in mobiles to start with? The cost of the mobile, the color of the mobile, and what can we do it as, or RAM of the mobile. I am making it as string because I'm gonna write GB as well, so that's why string. And now let's use getters and setters for this. Select all and OK. So we have our first class mobiles here. So our first type of inheritance was single inheritance. So I'll create one more class and I'm going to name it as Android. And I'll make Android as extends. Okay, I'll leave it for now. So this mobile class we are going to use afterwards. For now, I'll use only Android. So let me make it as string Android version. And for this, I'm gonna go for getter and setter. So what is single level inheritance? One class inherits from another class. So I'll create one more program, or I'll create one more class and I'm gonna name it as Samsung, because Samsung is an Android phone and as well as it comes under mobiles. So now I'm gonna extend it to Android. Extends Android. So no need of writing anything inside it. As soon as I write extends Android, I can use all the variables. Right now I have only Android version as the variable. So now let's go to main program and I'm write Samsung S is equal to new Samsung. So I just created an object of it. So now if I use S dot, I'll get Android version. So I'll set Android version as Android Pie. And now to show it, I'm gonna give it as Samsung Android version. And here S dot get Android version. So now I have Android class and a Samsung class, and I extended Android class to the Samsung. So Samsung can use all the variables here, and I can even set the variables here. So if I execute it, and here you go, you can see Samsung Android version, that's Android Pie. So without even declaring even a single variable or method here in Samsung, I used the variable of Android and I did this. So this is called as single level inheritance. So next I'm gonna move it for multi-level inheritance. So what is multi-level? One class is derived from next and this class is derived from here. So I have three classes right now. So I'm gonna put Android extends mobile. So now Android can use all the variables of mobiles. I can use cost, color or RAM, and even Samsung that extends Android can use all the variables from mobile. So if I put variables for it, S dot, see I can get color, cost or RAM. So I'm gonna go for set color. I'm gonna give it as black. And next S dot set cost. Cost I'm gonna give it as 30,000. Let it be dollar or rupees. And the last one S dot RAM. I'm gonna give it as 4 GB. So now if I print, I'll just delete all this. So now I can print them one by one. So let's just do that. So I'm gonna give it as Samsung mobile details and then cost S dot get cost. Next I'm gonna give it as color plus S dot color, S dot get color. And next last one I'm gonna give it as RAM plus S dot get RAM. So now you can see I have not declared any variable inside Samsung, but I inherited all the variables from here, mobiles and Android. So all the variables from mobiles are here, and as per Android, if I put Android version S dot get Android version. So now if I execute it, I'll get all the values and as a result I'll get everything that I gave as the value. So now let's just execute it. So instead of cost I should put color. So as you can see, I have the cost of Samsung mobile, color and RAM and even Android version. So all these variables I gave in mobile and Android version I gave in Android class, but nothing in Samsung class. So this is how multi-level inheritance works. So now let's move on to the third topic, that was hierarchical inheritance. So what is hierarchical inheritance? In that, three classes or two classes have a single base class. So I'm gonna create two more classes that derives Android. So now let's create them. Next I'm gonna name it as Nokia. And the last one, Xiaomi. So these are real-time examples, three mobiles, we have three different companies and all uses Android and they all come under mobiles. So now in everything I'm gonna write extends Android. So this is the final version of inheritance that we have, and this is very simple to understand, but it might get complicated when we use big programs or very large programs for some project. So now I have nothing inside class Nokia or Xiaomi or Samsung. I'm going to use all the variables that come from Android and mobiles, as Android extends mobiles. So this is the concept, like I have three classes, three mobile companies that comes under Android, and we can use them to manipulate the variables and assign values to the variables. So I already have everything from Samsung. So first let's create objects for all these classes. Nokia N is equal to new Nokia, and Xiaomi X is equal to new Xiaomi. So now I'm gonna assign variables to their values. So now let's start with Nokia. N dot set color, let's give it as red. N dot set cost, I'm gonna give it as 40,000. Again, doesn't matter because it's a normal program, so it doesn't matter whether it's dollar or rupees. So next, N dot set RAM, RAM 4 GB, and lastly N dot set Android version, Android Marshmallow. So, and in the end I'm gonna give X dot, let's just copy paste it, so it will be a lot easier for me to code or for you to code. So here X dot, and color I'm gonna give it as silver, rate 50,000, RAM 6 GB, and Android, let's give it some old, so KitKat. So now we have set all the values to the variables. So now let's print them as well. So again I'm gonna copy paste all those details. Instead of Samsung, Nokia, here it gets N instead of S, and now again copy paste. Now Xiaomi, X dot X, and finally X. So with this I have completed the program. I can show you all the values that I gave in the starting. Let's just revise it. So in mobiles I gave all the variables, cost, color, and RAM. Android I extended from mobiles and I gave one more variable as Android version. Nokia, Xiaomi, and Samsung I gave nothing, but I only extended Android. So now let's execute it. So we have successfully executed our program. Let's have a look at it. So here Samsung mobile details in the starting, color, cost. After that Nokia mobiles, and in the end Xiaomi mobile, and everything that we gave as the value are here. So with this we have completed our program. I hope you understood what inheritance is. So I'll just revise it one more time. So in single level inheritance I used only Samsung, Android, and mobiles. And Samsung I derived from Android and I used only Android version in the starting. Next I used multi-level inheritance. In that I used mobiles, Android, and Samsung. With the use of mobile variables I used Samsung and I printed the values of color, cost, RAM, and Android version as Samsung. In the next, that is hierarchical inheritance, I used Nokia, Xiaomi, and Samsung. So I hope you understood what the concept of inheritance means.
What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom It can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor, and we're going to do some animal sounds with cows, cats, and dogs. Just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package, and we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here. And we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just, good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in let's start with a cow. Why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class. But a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog. Why not? So here comes in our dog. And of course we want the dog to actually say something. And we'll have the dog go bow wow. And then we'll go back to our animal main and we have to create a dog. And we'll say cow. Simply dog dog. uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound, so we'll go down here and go dog.sound. And when we run this, as you expect, it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and it went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, in Java, the process of method overloading is achieved when a class has two or more methods with same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string, and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if-then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this one's going to print out the dog says growl growl. Now if we go back to our animal main, and here's our dog, same sound, but now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl growl. So the dog says bow wow, and then the angry dog says growl growl. So there is another thing called operator overloading. Operator overloading is not supported in Java. Authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here the overriding method gets resolved in execution. So far we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, This is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super.sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl, growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains, and it's printing out or doing whatever it does here. At this point, we usually have it return something, so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by a compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs to handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as the method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see where as you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then actually it's very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. Just depends. The more you use it, the easier it is.
Say you had to print hello all 3 times. You could do it by typing hello all in the system 3 times. But what if you had to print 100 times? What if you had to print 1,000 times? The solution to this is the use of looping statements. There are 3 types of loops that are used in Java: for loop, while loop, do while loop. When some condition evaluates to be true, these loops execute a set of instructions.
What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic, where we face the Java Collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java Collections API. To understand these in a much better way, we shall now go through the Java Collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65. And the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in 3 names, which are David, John and Stacy, into our list, and also we have a 4th addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the 4th element, which is the duplicate of the 3rd, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the 4th element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or pull. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits, apple, mango, grapes and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the DQ interface. So what exactly is a DQ interface? So a linear collection that supports element insertion and removal at both the ends is called as a DQ interface. The name DQ is short for double-ended queue and is usually pronounced as DEQ. Most DQ implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted DQs as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the DQ. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for DQ interface. So here we are going to add in some elements into our DQ and then also try to remove the first element and print the updated DQ. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the DQ were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that the updated DQ is having 2 elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains three general-purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add three elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names are been arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron, and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly, and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that, we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally, we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this, we finish the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3 and 4 in the matrix form, and we are going to use 2 for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3 and 4, and the elements are printed in the matrix form. At the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked lists also come under Java collection classes. There are 3 types of linked lists, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into 2 parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation, which stores the second element, similarly the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3 and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3 and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have 2 address locations. So the first address location of the head stores null, and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have 2 addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4 and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3 and 4 and 5. So this is how the doubly linked list work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6 and 7 and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for HashMap class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in this order. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally, increased speed in programming. So these were the major benefits of Java collections. What is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arises is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic, where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors. For example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see on our screen, we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string abc has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen, we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources. We will discuss the right angle triangle pattern. So basically, the right angle triangle star pattern looks something like this as it is shown on my screen. So to resolve this problem statement and print the pattern, we must assume that this particular star arrangement is made in the form of a matrix, where the first row has single star and the second row has 2 stars, third row has 3 stars, and so on. Now to execute this particular code, we might need 2 for loops. So the first for loop will be for printing the rows and the second one will be for printing the columns. Now let us execute a practical program and see how does it work. Don't worry about the codes that we will be executing here, because I have formatted a draft about all the codes that I will be executing today, and that particular file will be attached in the description box below. So I think my screen is visible to all. On my screen, you can see the particular pattern, which is a right angle triangle star pattern. So as discussed before, we will have the first outer for loop, which will be for printing the rows. So inside the outer for loop, we have the second for loop, which we will be using for printing the columns. You can see I have defined the row value as 5, which means we will be printing the star pattern for 5 rows. And we have used a counter variable, which is I, which is assigned the value of 1, and the comparator operator is used here, which is I should be less than or equal to the number of rows declared, and followed by that we have a pre-increment operator, and once the condition is true, the control will be entered into the second for loop where we have the next counter variable, which is j. So we have assigned j is equals to 1, and the comparator operator, which is j should be less than or equal to I, which is the value here, which is in the outer for loop, and followed by that we have the pre-increment operator. Once the condition is true, the control will enter into the inside for loop and will print a star. So here, just let us assume that the value of I is 1 and the statement is true. So the control will enter into the second for loop and it will see the conditional operator here. So j is less than or equal to I. So value of 1 is less than or equal to 1 and the star will be printed. After that we have the pre-increment operator. So here the j value will be incremented to 2. Now if we compare the values, 2 is not less than or not equal to 1. So the condition fails here. So it will not print a star again. It will come out of the inner for loop and it will see the next statement which says it should print in the next line. Whereas in the inside for loop you can see we just used print, not print in the new line. So it will come to the new line and go back to the for loop again and the increment of I will be taken place and the same runs again. Now let us try to execute this program and see the output. So you can see that the program got successfully executed and the right angle triangle star pattern is printed successfully. Now let us go into the next type of program. So the next type of program is the inverted right angle triangle star pattern. So similarly, according to the previous example, we also consider this one in the form of a matrix. So you can see that in the first row we have 5 stars. In the second row we have 4 stars. Similarly, so on. Now let us try to check out the code and learn how does it work and how to print the star pattern on our screen. We are back in the practical mode again. So the kind of pattern that we wanted to print is this one, which is a little bit similar to the previous one, but only thing it is inverted. So the code is pretty much the same, but the only changes that we need to do are related to the comparator operator. In the previous example, we chose that I should be less than or equal to 1, and in the next stage we used pre-increment operator. In here we are using a different one, which is pre-decrement, and inside the for loop we have the j comparator operator in the same way. So here we have declared the row value as 5, and inside the for loop we will equate the counter variable equals to rows, which is 5, and followed by that the comparator operator compares if the value of 5 is greater than or equal to 1, and followed by that we will use the pre-decrement operator. Once the condition is true, the control will enter into the inside for loop, and here the counter variable j is assigned to the value 1 and the condition is j should be less than or equal to I, and followed by that we have the pre-increment operator, which is ++ j. So once the condition is true, it will print the value of a star, and followed by that it will again continue the loop. So here the for loop will work in the following way. Int I is equals to 5, I is greater than or equal to 1, which is true, and pre-decrement. So the condition is true, so the control will enter into the inside for loop where it will again compare with value of j. J is equals to 1 and j is less than or equal to 5, and followed by that we have the post increment. So the control will enter inside the for loop and print a star, and followed by that in the next instance the value of j will be incremented to 2. So 2 is less than or equal to I, followed by that pre-increment, and in the next iteration it will print a star again. So this will continue until the condition is true. Once the condition fails, the control will exit the for loop and print in the next line. You can see that we have print in the new line here, which is unlike the print function which is inside the for loop. So this will continue until the statements are true. Now let us try to execute this program and see if the desired pattern will be printing or not. There. You can see that the program got successfully executed and the pattern which we desired for is printed on the screen. Now let us move ahead into the next type of pattern. So the next type of pattern is the arrow-shaped pattern, and this almost looks familiar to the previous two programs. The only difference is we have combined them together to form an arrow pattern. Now let us try to combine the previous two programs and print this. So now you can see on my screen we have our desired pattern, which looks like an arrow. So as discussed before, we are trying to combine the two programs that we executed before. So the first half of the program is designed for the first half of the pattern, which is completely similar to our first program. So the second half of the pattern is from our second program. But the only difference here is we have considered the value of rows is row -1 because we don't want another extra row to be printing here in this way. So you can see if we used I value is equals to rows, then the pattern would be something like this. We will not have a pointed edge. So to get a pointed edge, we will use row -1 to get this pattern what we desired for. Now let us try to execute this program and print the output. Now let us enter the number of rows we want. Let's enter 5. So there you go. Let me expand my output screen. Yeah, there you go. We have the pattern which we desired for. And don't forget that we need to use row -1 in the next stage, which is the second half of the program. So this is how the arrow pattern is printed. Now let us move further and see the next type of pattern in our list. So in the next pattern, we have the right angle triangle, which is completely similar to the first one, but the hypotenuse is on the other side. As you can see, this is the difference between the first program and this program. So in the first program, we had the hypotenuse in this direction, and now we have the hypotenuse in the opposite direction. Now, similarly to the first program, we shall consider this one as well in the form of a matrix. So you can see, if we consider this pattern in the form of a matrix, we have 4 spaces followed by a star. Similarly, in the second row, we have 3 spaces followed by 2 stars. In the third one, we have 2 spaces and 3 stars, and so on. So the main point that we need to consider here is, first we need to print the spaces. Followed by that, we need to print the stars to get this pattern. Now let us execute a practical program and see the output. So back in the practical mode, you can see on my screen the desired pattern what we are looking for is this. So here the only difference is we have to print the spaces first. So for printing the spaces, we will be using this for loop with the condition j is equals to 2 into n minus I, and j should be greater than or equals to 0, and j decrement, which is a post decrement operator. So what is the value of n? N is nothing but the value of rows. So the value of n is declared in the main function, and n is equals to 5. After that, we will be calling the print stars function, which is over here, and the value of n will be carried over here, and then the counter variables I and j will take care of the for loops. Now let us try to execute this program and see the output. So you can see that the program is successfully executed and the desired pattern is printed successfully. So this for loop will be run until the condition is true. Once this for loop fails, we will enter into the next for loop, which is particularly designed to print the stars. Now after this, let us move ahead into our next type of pattern. So the next type of pattern is an inverted right angle triangle pattern, which is opposite to the second type of program that we dealt with. Now similarly, let us consider this in the same way as we considered all the other programs, that is in the form of a matrix. So here we have 5 stars in the first row, 4 stars in the next one, and 1 space. Followed by that we have 2 spaces, followed by that we have the 3 stars, and 3 spaces, 2 stars, and so on. Now let us see a practical program and try to print this particular pattern. So we are back in the practical mode, so you can see that the desired star pattern is this, and it is completely similar to our previous pattern. So the only difference is we tried to print spaces first in the earlier pattern, and here we are trying to print the stars first. So that's the only difference. And we have the same for loops. So the first for loop is for rows and it will print spaces, and the second for loop is for stars, which will print the stars. As you can see, we have the row values and the column values here as the comparator operator, and we have the comparator operator which finds if j is greater than I. In the first case, the loop will fail because the value of j and I are completely similar, because we have declared I is equals to rows in the first outer for loop and same j is equals to rows in the second inner for loop. So obviously the condition has to fail and it will not print any space here. It will directly enter into the next for loop and will print the star pattern, and followed by that we will enter into the next line. So this for loop will print the number of stars in the first row according to the row number. For example, if we give 5 as the row number, then it will print 5 stars in the first row, and it will exit the for loop and it will enter into the next line, and the same pattern will be continued. Now let us try to execute this program and see the output. Now let us give 5 as the number of rows needed. So there you go, you can see the star pattern here. So this is how this particular star pattern will be generated. Now let us move further and check out the next type of pattern program in our list. So the next type of pattern program in our list is arrow. So this arrow is completely similar to the previous one. The only difference is it is in the inverted way, which is it is pointed towards the left side. Now let us check out the practical program and learn how to execute this. Back onto Eclipse IDE. So you can find some similarities between the previous two programs and this particular program. In the previous two programs, we tried to print the first half of the pattern, and followed by that, we have printed the second half of the pattern. Now we are going to just combine both the programs and print this particular arrow pattern. So here, the first half of this particular program is concerned with the top portion of this pattern, which is the right angle triangle. Followed by that, the second half of the program where we have the conditions placed. So this particular segment of the code takes care about the second half of the program, which is the inverted right angle triangle. Now let us try to execute this program and see the output. So let us specify the number of rows as 5, completely similar to the previous two programs. Now let's press enter. Now there you go. Let me expand my console. So there you go. You can see the arrow pattern. So this is how you print an arrow pattern pointing towards the left side. We have also discussed an arrow pattern where the arrow will be pointing towards the right side as the program number 3. Again, don't worry about the codes. All the programs that I'm going to execute in this session are drafted in the form of a text document, and that is linked in the description box below. You can take that source file and practice the programs for yourself. Don't worry. Now let's move ahead and check out the next type of program. So the next type of pattern that we have in our list is the pyramid. We also call this an acute angled triangle star pattern. Now let us understand the logic for this. Now you can see without the matrix format, this looks completely similar to our first program, but only the difference is we have a space, which is obvious, but there is a small difference. Let us check out what the difference is. If we look this program in the form of a matrix, you can see there are variations in spaces. In the first row, we have 2 spaces, 1 star, followed by that again 2 spaces. In the next row, we have alternate space and star, space and star, and similarly in the third row we have a star, space, star and space. So this is how the matrix continues according to the number of rows provided. So let us understand how the logic exactly works for this program. Okay, so you can see The pattern that we desired is in the form of an acute angle triangle or pyramid. Now we have two counter variables, which is I is equals to 0 in the outer for loop and j is equals to n minus 1, which is inside the for loop. So the value of n is equals to 5, which is the total number of rows that we needed in our particular pattern. Now you can see in the outer for loop we have the condition, which is I should be less than n. So I should be less than the number of rows, which is equals to 5. Followed by that we have the post increment operator I++. So the condition will be true because 0 is less than 5 and it will enter into the inside for loop where we have j, which is equals to 5 minus 0. Followed by that we have the condition. So 5 is greater than 1. So the resultant of this particular statement is 5. So 5, which is now the value of j, is greater than 1. Followed by that we have the post decrement operator, which will decrease the value of j in every iteration. So once the statement is true, it will try to print a space. So it will print the spaces until the condition is true. So once the first for loop fails, the control will enter into the next following for loop where we have j is equals to 0 and j should be less than or equal to the value of I, which is currently equals to 0, and followed by the conditional statement we have the post increment operator, which is j++. So this particular for loop is used for printing two things, which is the first one star, followed by that we have a space. So once this for loop gets executed, the control will exit it and will print in the new line. So this is how the program works. Now let us try to execute this program and see the output. There you go. The program got successfully executed and the required spaces and the stars have been printed here. So as you can see, we have spaces, followed by that we have a star. Similarly, space, spaces onto the left, a star and the second star. So followed by the previous program, we have the next program, which is also considered to be like a pyramid, but the only difference is it is in an inverted format. Now let us check out the logic behind this program and try to execute a practical program. So logic wise, it's completely similar to the previous one. We have star, followed by that we have a space, and again a star, space and a star. Next row we have alternate space and star, and finally we have two spaces, star and two spaces. So the number of spaces and stars is based upon the number of rows we provide. Now let us try to execute a program and see the output. Don't worry, this is completely similar to the previous one, but the only difference is it is printed in the inverted fashion. So there will be minor changes to the code. Let's try to look on those changes. So here we are back in Eclipse. So the desired pattern is here, which is an inverted pyramid, and the previous program was a regular pyramid. So here is the logic, and we have the following for loops. So the first for loop is dedicated for printing the number of spaces we require. So inside the exterior for loop we have the counter variable I is equals to 0, and I should be less than or equals to the number of rows minus 1, and followed by that we have the post increment operator I++. So let us assume that we have provided the number of rows to be 5, and according to the logic I is equals to 0, and followed by that 0 is less than or equals to 5 minus 1, which is 4, and followed by that we have the post increment operator, which will increment the value of I to 1 once after the for loop first iteration is finished. So once the exterior for loop condition is true, the control will enter into the second for loop, which is the internal for loop, and we have the second counter variable, which is j is equals to 0, followed by that the comparator operator, which says j should be either less than or equal to the value of I. Followed by that we have the post increment operator on j. So this particular code segment, or the first part of the program, takes care about the number of spaces we require in our pattern. Followed by that we have the second for loop, which will take care of the number of stars we print and the number of spaces we require after the star pattern. Now let us try to execute this program and see the output. Now let us provide the number of rows we need. Let's provide the value as 5. Now there you go. According to the logic provided in the program, the star patterns are successfully generated followed by the spaces. Now moving ahead, we have the next type of pattern, which is the combination of first and second pyramids. Now let us understand the logic and print this pattern. Now you can see the desired pattern is the combination of the first pyramid and the second pyramid. So the first half of the program is derived from the first pyramid pattern, and the second part of the program is derived from the second pyramid pattern. Now we have combined them together, and now we are trying to print the rhombus pattern. Now let's try to execute this program and see the output. Let us provide the number of rows as 5, and there you go. So here you can see the desired star pattern has been successfully executed. So according to the input, we have the first 5 rows, and followed by that we have the inverted star pattern, where we avoided the first row and printed the following 4 rows, so that we have a proper Rubik's pattern. Now moving ahead, we shall see the next type of pattern in our list. So followed by the previous pattern, we have the next type of pattern, which looks completely similar to the previous one. But the only difference is we have printed the second type of pyramid first and then the first type of pyramid, which makes it look like an hourglass. Now let us understand the logic and print this pattern. So here is the desired pattern what we are looking for, and this was the previous pattern what we printed. Now followed by the first segment, we have the second segment, which is dedicated to print the second half of the pattern, which happens to be the first type of pyramid, which is a regular pyramid. But the only difference is inside the first for loop, we are using the rows -1 command, because we don't want an extra star. So if we add in an extra star, this pattern will look a little abnormal. So let us try. So this is what it looks like if we had an extra star there. So let us remove it. So this is how our pattern should look like. So that's the reason why we are using row -1 here. Now let us try to execute this program and see the output. Now let us enter the number of rows we want. Let us input 5. Enter. So there you go. You can see the program got successfully executed and the desired star pattern has been printed on the console. Now let us move further and have a look on the next type of pattern in our list. So followed by the hourglass pattern, we have the next pattern where we need to print a diagonal star pattern. Now if we look at the logic, it's just a single line which is placed in the form of a diagonal. Now let us check the logic behind it. So you can see we have printed stars in the form of a diagonal of a matrix. Now we have the first 4 spaces, followed by that we have a star, and similarly 3 spaces provided by a star, then a space, and so on. Now to print this pattern, what's the logic? Let's go back to Eclipse and try to print this program. So this is our desired pattern. Now let us go into our program. Now inside the program we have 2 counter variables, which are one I, 2 is j. So the first for loop is I is equals to 1, I is less than or is equals to 5, which is the row number, then I post increment. So when the logic is true, which is 1 is less than or equal to the row number 5, the control will enter into the second for loop. So once the control enters into the outer for loop, we have the second for loop where we have our second counter variable, which is j. J is equals to 0 and j is less than 5 minus I, which is 5 minus 1, which is the current value of I, which is 4. So 0 is the value of j currently. So 0 is less than 4. Followed by that we have the post increment on j counter variable. So once the condition is true, the control will enter into the second inner for loop and will print space. So this loop will run until the condition is true. Once the condition fails, it will come out of the inner for loop and will print a star in the new line. Followed by that, it will continue to start the outer for loop again. So this is how the flow goes ahead. Now let's run the program and see the output. So you can see the program got successfully executed and the desired pattern is printed. Now let's move ahead and understand the next type of pattern in our program. So the next type of pattern is a little bit similar to the previous one. So in the previous pattern we had one diagonal. Right now we have two diagonals which have formed the shape of X. So we can consider this as an X pattern. Now let us check out the logic, and next after that let's execute the program. So according to the logic, when we consider this particular pattern in a form of a matrix, we have the stars printed in the first row, followed by that we have 3 spaces and then again a star. So this is continued in the same way with alternate spaces, and in the third row we have a single intersection point with 1 star. So this is how the pattern should look like once the program gets executed. Now let us check out the program and see the output. So you can see on my output console, this was our previous pattern. Now what we are going to do is make a similar pattern in the opposite direction and make sure they intersect each other. Now you can see our program has 2 segments, the first segment and the second segment. They both look a little similar because the first segment will print the upper part of the pattern, that is the first V, and then the second segment will print the lower part of the pattern, which is the inverted V. Now let us check out the condition. We have the first outer loop which has the first counter variable, which is I is equals to n. N is nothing but the number of rows that we want in our pattern. Then I should be greater than or equal to 1. Followed by that we have the post decrement operator where we will decrease the value of I. Then if the condition is true, then the control will enter into the next statement where we have the inner for loop with second counter variable, that is j is equals to I. Then the condition is j should be less than the value of rows provided. Then post increment of j, and if the condition statement is true, then it will enter into the inner for loop and it will print a space. Similarly, for printing the star, we have the next segment. Inside the next segment, the condition is a little trickier because we don't want to print any stars in the space between the X pattern. We provide this condition where j is equals to 1 and j should be less than or equals to 2 times the value of I, which is the outer for loop, minus 1. If this condition is true, the control will enter inside the for loop where we have if else condition. If j is equals to 1 or j is equals to 2 into I minus 1, then we should print a star. Else we should print a space. So this will print the upper part of the pattern, and similarly we have another segment which will print the lower part of the pattern, which is the inverted V pattern. Now let's execute this program and see the output. As you can see, the program got executed. Now let us provide the value of n. Let us provide 5, and there you go. You can see that the program printed the desired pattern. So this is the first half of the pattern, which is the proper V. Then this is the second half of the program, which is the inverted V. So this is what the flow of the program is. Now let us move further and check out the next pattern in our list. So the next pattern in our list is the inverted V pattern. Now let us check out the logic behind it. If you see this in the form of a matrix, then you can recognize this. We had already discussed similar program, which was the third one, where we had printed the pyramid shape. But the only difference is we have missed out the star in between, which makes it look like a inverted V. Now let us go back to Eclipse and execute a program based on this to print this pattern. As you can see, we have our desired pattern on my screen, which is an inverted V. So if we check out the logic, we have outside loop and inside loop. So we have 2 for loops. So the first outer for loop has out is equals to 1. Out should be less than or equals to the number of row size, then post increment of outside variable. If the condition is true, we enter into the inner for loop where we have inner loop is equals to 1. Inner loop should be less than or equals to the row size into 2. Then we have increment operator, which is a post increment. So if this particular condition is true, then we enter into another statement where we have the if else statement. So if in value is equals to control X, or in is equals to print control Y, then we should print star, else we should print a space. Now let us try to execute this program and see the output. Now let us provide the row size, which is 5. So as you can see, we have got our desired pattern. Now let us move ahead and execute the next type of pattern, which is the V pattern. Now let us understand the logic behind it. It is completely similar to the previous program, but the difference is the pattern is in inverted position to the previous one, which is in the proper V format. So now let us try to check out the code and execute the program and print the pattern. So on my screen you can see the desired pattern what we are looking for, which is V. Now the previous program was to print an inverted V. So the complete program is same, but only there is a minor change in the logic where we have replaced I as greater than or equals to 0. And there is some change in the second segment as well. Now let us try to execute this program and see the output. So you can see the program got successfully executed and the desired pattern is printed here. The value of n, or row size, is equals to 5, which we have declared here in the main part. Now let us get back and check out the next pattern to be executed in our list. So the next pattern is the combination of both an inverted V and a normal V, which will result in the form of a rhombus. Now as you can see, this is our previous program. Now we have two segments in our code, where we have the first segment to print the starting or the top position, which is an inverted V format, and the second segment of the code is designed to print the second half of the pattern, which is the normal V pattern. So we will combine these two and print the rhombus shape. Now let me provide the number of rows, which is 5. So there you go, you can see the desired pattern. Now let us move ahead and check out our next pattern. So the next pattern is completely similar to one of the previous ones, which is a pyramid pattern, but the difference is this pyramid is hollow, or in other words, this looks like an acute angled triangle. Now let us understand the logic behind it. So if you look at this matrix, then you can find that we are going to print the stars in the form of a side of the triangle, which is we will print the stars in the shape of a triangle and nothing inside the matrix. Now let us understand the program and print this pattern. So as you can see, the desired pattern is being located here, which is a triangular pattern. Now inside this, we have three particular for loops. So the first for loop is the outer for loop, and the rest two for loops are the internal for loops. So the first internal for loop is dedicated to print spaces where we don't require stars. And the second internal for loop is dedicated to print stars where we require them. Also we have an if-else condition which decides where to print a star and where not to. Now if we look at the condition, I should be less than or equal to the number of rows provided, and if the condition is true, then we enter into the internal for loop. And in the internal for loop, if j is less than the number of rows given, then in that particular location we need to print a space. Once the condition in the first for loop is failed, the control will enter into the next for loop where we have the next counter variable, that is k is equals to 1, and k should be less than or equals to 2 into I minus 1, where the value of I is 1 at the current stage, and followed by that we have the post increment of the value of k. If k is equal to 1, or I is equal to the number of rows, or k is equal to 2 star I minus 1, then we should print a star. So this will give the location in the matrix where we should print star to make it as a triangle pattern. If location is anything else than the condition provided, then we should be printing space there. Now let us try to execute this program and see the output. Let us provide the number of rows as 5. So there you go, we have printed the desired pattern. So the next pattern after the triangle pattern is the box pattern. So this particular program will be completely similar to the previous program. The only difference is we need to find the locations where we need to print stars so that the resultant pattern looks like a box. So for that, we will make some changes in our program, and those changes will be related to the rows and columns. Now let us understand the logic. So as discussed before, we need to look at this pattern in the form of a matrix and check out the number of rows and columns. So where the number of row and column are equal, we need to print a star. So let us now check out the program and execute the program to print this particular pattern. So as you can see on my screen, we have the same program that we used to print the triangle, but now here we have rows and columns. So n is nothing but the row and m is nothing but the column. So if the value of the external for loop, that is I is equals to 1 and I is equals to the number of rows provided, similarly j is equal to 1, which is the internal for loop counter variable value, and if j is equals to m, that is the column value, then we should print a star in that particular location, and wherever the location does not match, we should provide a space. Now let us try to execute this program and see the output. So there you go, we have our desired pattern, which is the box pattern. Now let us move ahead and check out the next type of pattern in our list. So you can see the next pattern is completely similar to our first pattern. The first pattern was our right-angled triangle. Now we have the same right-angled triangle, but the only difference is we have used numbers here. Now we will use the numbers from our for loops and we will print the same values in our pattern so that it looks like a right-angled triangle. Now let us understand the logic. So we will see this pattern in the form of a matrix. Now we will print the numbers where we require them. Where we don't require the numbers, we will print spaces. Now let us check out the program and execute it to print the following pattern. Now you can see we have got back to our same program, but the only difference is here we are using the values of the inner for loop, which is j, instead of a star. Previously we used star symbol here, and we are now replacing it with the inner for loop value. Let us try to execute this program and see the output. Now let us enter the number of rows as 5, and there you go. We have the values of the internal for loop, making the pattern look like a right-angled triangle pattern. Now let us move further and check out on our next type of pattern in the list. So here is another right-angled triangle in our list, but the difference is we are using the numbers in a continuous manner, which is 1, 2, 3, 4, 5, 6 to 15. This type of triangle is also called as Floyd's triangle. Now let us understand the logic. So similar to the previous one, we will consider this in the form of a matrix, and we will print the numbers only where we require them, that is to form a right angle triangle. Where we don't need the numbers, we will try to print a space there. Now let us check out the program and execute it and print this pattern. Now you can see we have got back to Eclipse. And don't get scared about the pattern, it's completely similar to the previous one. Only thing is we will be using one extra counter variable, which is k. So we have provided the value of k is equals to 1, and where we are supposed to print stars, we will add the post increment operator to the counter variable k. So whenever the for loop gets executed, we will be printing the values of k, which is 1, 2, 3, 4, 5 and so on. Now let us try to execute this program and see the output. So there you go, the values of k, 1, 2, 3, 4, 5, 6, 7 until 15. So this is how the Floyd's triangle works. Now let's get back and check out the next pattern in our list. So the next pattern in our list is similar to the previous one, which is pyramid. So this type of pyramid is also called as Pascal's triangle. Now let us check out the logic. The logic is completely similar to the pyramid's logic, but instead of star, we are going to use numbers. So this type of triangle is called as Pascal's triangle, and the logic is also a little bit different from the regular pyramid. Let us understand the logic through the code. So now you can see the program on my screen. So the logic and the for loops used are completely similar to that of the pyramid, but only the difference is we are going to print the value of number. So the number is firstly initialized as 1, followed by that we have a formula for that, which is number is equals to number into I minus j divided by j plus 1, which are the values of the counter variables of outer for loop and inner for loop respectively. Now let's try to execute this program and see the pattern. So you can see the program got successfully executed and the Floyd's triangle has been successfully constructed here. Now let us move ahead and check out the next pattern in our list. So the next pattern in our list is a box which is made up of binary numbers. Now let us understand the logic for it first. So if we look at this in the form of a matrix, we have binary numbers 1 and 0 which forms the pattern of a box. Now let us check out the program and execute the program to print this particular pattern. So you can see on my screen we have the program to print that particular box type of pattern using the binary numbers. So we have the external for loop for rows and the counter variable I is equals to 1 and I should be less than or equal to the number of rows provided. Once the condition is true, we enter into the external for loop where we have the number and where we have the condition I modulus 2 is equals to 0 and the number is equals to 0. And inside that we have our logic to print the binary numbers. Now let us try to execute this program and see the output. Now let me place the number of rows as 5 and there you go, we have our box pattern using binary numbers. Now let us get back and check the next pattern in our list. So the next pattern is the Ruby pattern. This is completely similar to our program where we printed the Ruby pattern using the stars. Now we'll use the numbers and print that particular pattern. Now the logic for this is completely same that of the Ruby pattern we used, but the only difference is instead of a star, we'll be placing the value of the counter variables. Now let us try to execute this program and see the output. So there you go, the program got successfully executed and instead of stars, we have printed the Ruby pattern using the numbers. Now moving ahead, we have our next pattern. So here, the next pattern is completely similar to the first one, which is the right angled triangle pattern, but here instead of numbers or stars we will be using alphabets. So for alphabets we will be using the ASCII values in the program. Let us check out that program soon. Now first let's understand the logic. The logic is also completely similar to the right angled triangle which we followed for stars and numbers. Now let's check out the program. So as you can see, the desired pattern is the right angled triangle made out of alphabets. So the logic is completely true, but the only difference is we are going to print characters using ASCII values and alphabet function. Now let us try to execute this program and see the output. So the desired pattern is the right angled triangle printed using the alphabets. Now the logic is completely similar to the right angled triangle pattern, but the only difference is we are going to use the ASCII values. So we have declared an integer type variable alphabet with the ASCII value 65, which should start the alphabets from capital A because the ASCII value of capital A is 65. Now let us run the program and see the output. So there you go, the program got successfully executed and we have the right angled triangle printed using the capital alphabets. Now let's get back and check out our next pattern. So our next pattern is a pyramid again. So instead of numbers and stars, we are going to use the alphabetical values. Now let's check out the logic. Even here you can see the logic is similar to the pyramid logic. Now let's check out the code and execute the code and see the pattern. Now you can even see the logic is also similar to the pyramid logic. But here the only difference is we are going to use the ASCII value, that is 65, which is equivalent to capital A. Now in the print statement, instead of a star, we are going to print the alphabets. And this particular for loop is for spaces. Now let's quickly execute this program and see the output. So there you go. The pyramid pattern has been successfully printed. So with that, we come to an end of this crash course. I hope it helped you. We will be back with more videos soon. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.